Find the roots of the equation z square plus 2 under root z, 2 under root 3z plus 4. All right, so since a, B, C, all three of them are real, we'll notice that our roots are complex conjugate pairs. All right, so to solve a quadratic equation, we're going to apply the quadratic formula minus B plus minus square root B squared minus 4AC upon 2A. Okay, what will the discriminant become? 2 squared is 4, 4 into 3 is 12, minus 16 over 2, which gives minus 2 under root 3 plus minus under root negative 4 over 2. The square root of negative 4 is 2 iota. So 2 and iota over 2. So we're getting minus 1 under root 3 plus minus iota. Let's write this separately. So minus under root 3 plus iota or minus under root 3 minus iota. These are the two roots. Okay. State the modulus and argument of each root. Okay. So for that, it's advised you plot it on an Argand diagram first. Negative under root 3, 1, and negative under root 3, minus 1. Okay, so the modulus for both of them would be the same. Distance from the origin, that is going to be, let's do the working here, r equals under root, apply Pythagoras theorem, under root 3 whole squared plus 1 squared. We've applied Pythagoras theorem on this triangle, ignoring any negative signs. This becomes 3 plus 1, 4, square root of 4 is 2. So both of these have a modulus of 2. Okay, let's find their arguments. For the arguments, we will find this angle and then subtract it from pi to get this. And for this one, we're going to find this angle, which we would have already found earlier, and then find this angle and put a negative sign instead because that's clockwise angle. So the arguments will also come out to be the same but with the opposite sign. One would be positive, the other one would be negative. All right, so the argument would be, or the theta here would be, theta is equals to tan inverse y over x. So y is 1, this is 1, and x is under root 3. Ignore any negative sign. Tan inverse 1 over under root 3 gives 1 over 6 pi. So now we do pi minus 1 by 6 pi, which is 5 over 6 pi. So the argument for both of them is pi 5 by 6 pi, and for the other one, it's negative 5 by 6 pi. So for this one, let's call it C1 and let's call it C2. So modulus of C1 is 2 and argument of C1 is 5 by 6 pi. Modulus of C2 would be 2 and modulus argument of C2 would be minus 5 by 6 pi. Okay. Then the next part is show all your working, verify that each root also satisfied z power 6 equals negative 64. Okay, so we will now find power 6 of each root. Okay, what is that going to be? So for z power 6, let's call it z1 power 6 and z2 power 6. All right, so we're going to use the De Moivre's theorem here, which says if we need to find modulus of a power which is 6, what you do, you give the original modulus a power of 6. So this will come to power 6, which I believe is 64. Okay. And similarly, the modulus of z2 power 6, this one will also become 2 power 6, which is 64. For the argument, we will multiply the original argument with 6. So the original argument is 5 pi by 6, which becomes 5 pi. We will have to adjust it. Okay, so this will become 5 pi. I'll adjust it in the bit, and modulus of z2 power 6 would become, sorry, argument of this will become minus 5 pi because we multiply this with 6. Okay, so we will need to, do we need to adjust it? I believe not. We can just write it as a complex number. So this would be in polar form 64 cos 5 pi plus iota sine 5 pi. And this will become 64 cos minus 5 pi plus iota sine minus 5 pi. Okay, just to be safe, let's change 5 pi into the correct domain. The allowed domain in polar form is pi to minus pi. 5 pi clearly goes way beyond it. What is 5 pi? 5 pi in degrees is 5 into 180, that's 900. So 900 means that the angle is taking a couple of round trips. So 900 minus 360 is 540, minus another 360 is 180. So that means we take 2 round trips and then come over here. Okay, so that means it's the same as pi and minus pi. So we can replace this with pi and minus pi. All right, so just to stay in the domain, I'm going to change 5 pi's into pi. Cos pi plus iota sine pi, and this becomes cos minus pi plus iota sine minus pi. Okay, now this will become 0 for both of them, and this would be 1 for both of them. So we get 64 times 1 and 64 times 1. So we've shown that z power 6 is equals to 64 for both of the roots. I'm sorry, it becomes negative 64 for both of them because this is negative 1 and this is also negative 1. So this becomes negative 64 and negative 64. And that is what we were supposed to show, that z power 6 is equals to negative 64.